Hello everyone, let's do this problem. It says, give the complete ground state electronic configuration for the two elements having atomic numbers 8 and 16. So to determine our complete electronic configuration, we need to know the total number of electrons, right? So we get that information from the atomic number, which is given to us. The atomic number equals the total number of those ground state electrons. Okay, so now we want to draw our electron orbitals, right, the subshells, and fill our electrons in them in order to get our electronic configuration. So do we have to draw that in a special way? Yes, there are special electron filling principles that you may recognize. There's Aufbau's principle, the Pauli exclusion principle, and Hund's rule. So Aufbau's principle means, or tells us, that the lowest energy orbitals are filled first. So we have to completely fill the lowest energy orbitals before moving up to higher energy orbitals. The Pauli exclusion principle tells us that each orbital can have 2 electrons maximum, and they have to have an opposite spin. All right, and lastly, Hund's rule tells us that when we have orbitals with similar energy, right, so think of like the 2p subshell, which has 3 orbitals, those are all similar energy, we have to fill those orbitals singularly, so each orbital gets 1 electron, before pairing them, okay? So we have to fill orbitals with similar energy completely and singularly before pairing. Okay, and if that's confusing, you'll see what I mean when I draw it out. So let's apply this to the elements with atomic numbers 8 and 16. So for atomic number 8, we can draw the 1s subshell, 2s subshell, and 2p subshell, filling in from the lowest energy subshell, which would be 1s. We have 2 electrons. 2s would have 2 electrons. So that's 4. So we have 4 more electrons. Now we have our 3 2p orbitals. So they each get 1 electron, right? This is Hund's rule. And now we can start pairing. So that first orbital will get a paired electron spinning in the opposite direction. So now we write our electronic configuration with the subshell name and then the number of electrons in that subshell as the exponent. So the electron configuration for an element with atomic number 8 will be 1s2, 2s2, and 2p4. Okay. Now for atomic number 16, same principle, except we need some more energy levels, right? 3s and 3p as well. So we fill out 1s, 1, 2, 2s, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so now writing this in our condensed electron configuration. We have 1s2, 2s2, 2p6, 3s2, 3p4. All right, so those are the complete ground state electronic configurations for the two elements having atomic numbers 8 and 16. That's it for this problem. I hope this was helpful, and thanks for watching.